Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 10, Wave Optics. And this session is not problem solving session, it's a problem questionnaire session. That is, 7 questions will be sprayed in this session, and in next session we will solve the solution for this question. Let's move to question number 1. In a Young's double slit experiment, if there is no initial phase difference between the light from the two slits, then a point on the screen corresponding to the fifth minimum as path difference dash. Option A, 5 lambda by 2. B option, 10 lambda by 2. C option, 9 lambda by 2. D option, 11 lambda by 2. By knowing the formula for path difference in Young's double slit experiment, you can find the answer for this question. Let's move to question number 2. In a double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minimum formed on a screen placed 1 meter away was found to be 0.2 degree. Or what will be the angular width of the first minimum if the entire experimental apparatus is immersed in water? Nu of water is given 4 by 3. Option A, 0.15 degree. B option, 0.051 degree. C option, 0.1 degree. D option, 0.266 degree. That is, by knowing the formula for angular width with respect to refractive index, you are able to find the answer for this question. Let's move to question number 3. Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has a diameter of 2 meter is dash. Option A, 1.83 into 10 power minus 7 radian. B option, 7.32 into 10 power minus 7 radian. C option, 6.00 into 10 power minus 7 radian. D option, 3.66 into 10 power minus 7 radian. That is, you should know the formula for resolution with respect to diameter. By knowing this, you are able to find a solution for this question. Let's move to question number 4. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of dash. A, large focal length, large diameter. B, large focal length, small diameter. C option, small focal length, large diameter. D option, small focal length, small diameter. That is, you should know the formula for the angular magnification of the telescope. By knowing the idea about how is the focal length of the objective, like that, by knowing that idea, you are able to find the answer for this question. Let's move to question number 5. The ratio of resolving powers of an optical microscope for two wavelengths, lambda 1 equal to 6000 angstrom, lambda 2 equal to 4000 angstrom is dash. Option A, 8 is to 27. B option, 9 is to 4. C option, 2 is to 3. D option, 3 is to 2. You should know the formula for resolving power of a microscope with respect to wavelength. By having the idea, you are able to find the solution of this question. Let's move to question number 6. A beam of light of wavelength 600 nanometer from a distant source falls on a single slit 1 millimeter width, and the resulting diffraction pattern is observed on a screen 2 meter away. Distance between first dark fringes on either side of the central bright fringe is dash. Option A, 1.2 centimeter. Option B, 1.2 millimeter. C option, 2.4 centimeter. Last option, 2.4 millimeter. That condition for the brightness, condition for dark fringes, by knowing the idea, you will find the answer for this question. Let's move to last question, question number 7. The angular resolution of a 12.2 centimeter diameter of telescope at a wavelength of 5000 angstrom is of order of dash. A option, 10 power 6 radian. B option, 10 power minus 2 radian. C option, 10 power minus 4 radian. Last option, 10 power minus 6 radian. You should know the formula for angular resolution in terms of diameter and wavelength. By knowing the formula, you are able to solve this. Thank you, students. So in next session, we will solve how to find a solution for this question. Thank you.